In this lesson we will be looking at arithmetic and geometric series, which go along with sequences. And we will learn a little bit about that and this crazy symbol that you see on this page here. Alright, so first of all, a series is where you sum the terms of a sequence. So if it's just a sequence, like here, you just list the numbers 2, 5, and 8. If it's a series, you actually add up the numbers 2 plus 5 plus 8 over here. Okay, so there's an arithmetic one. You can see your common difference is that you're adding 3 each time. 2 plus 3 is 5 plus 3 is 8. And then there's obviously the same thing with a geometric sequence or series. Again, a geometric sequence is where you list all the numbers and you multiply by something to get to the next number. So here I'm multiplying by 3, of course, with a geometric sequence. And in a series, you're going to take each one of those terms and instead of just listing them, you will add them up. Okay, so that's what a series is. Here are some formulas that you're going to use for the different arithmetic and geometric series. And the SN formula is just sort of, it's kind of old school, but it does work. It is the sum formula. And then sigma, which is this crazy little kind of sideways E right here, is also another way you can deal with summing some series up, and we will talk about that. And if you choose to use that, your calculator is really helpful. So I will teach you to do both ways using both kinds of formulas for each sequence, and we will kind of use that as we talk about it. Okay, so in this first problem, I'm wanting you to find S30. So I'm wanting you to use the sum formula right here. And first of all, you need to pay attention to what kind of series it is or sequence it is. Notice I'm having 2, 4, 6, 8. This is an arithmetic sequence because 2 plus 4, or 2 plus 2 is 6, plus, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So since I'm adding to get to the next number each time, it is an arithmetic sequence that I'm dealing with. And I want to add up that arithmetic sequence, and so I am going to use the sum formula. Okay, so I will use this formula that is up here. So I want to find S30. Notice I have 30 down there for n, which basically means that I want to add up the first 30 terms. So I have the first 4 listed, and I will not let you just write 30 terms out and then add them all up. I'm going to make you use formulas. So when we use that formula, we're going to plug in 30 for n. A1, of course, stands for our first term, and we find our first term right here. That's 2. The problem on this one is I don't know the 30th term. So if I'm trying to find the 30th term, then the number that goes right here is A30, which is the 30th term. And I don't know the 30th term. Okay, so I'm going to come back to that in a minute. And of course, I will divide by 2. So again, what has to go right here is A30. Okay? The problem is I don't know it. So now you need to go back to your other formulas, and I am going to use this formula right here. You know that AN is A1 plus n minus 1 times d. So I'm needing to find the 30th term. I know the first term is 2. If I want to find the 30th term, I will put 30 in for n. And I can see that my common difference here each time what I'm doing is I am adding 2. So my common difference is 2. Okay? So I will basically have 2 plus 29 times 2. And so that will give me 60. Okay? So A30 is 60. And I will take that 60 and I will plug it in right here. And now I can find the sum of all of those terms. Okay, so the sum of the first 30 terms in this sequence would be 30 plus 62, or 30, sorry, no, let's do that. 30 times 62 divided by 2. And when I simplify all of that, I should get 930. Okay, so that is using the formula. Then we're going to talk about this sigma notation here a little bit. You have this in your notes. First of all, I want you to think about this. We're going to practice on our calculator, I think, with this one. And here we go. So, I want you to notice down here n equals 1. Here's what you need to do, okay? This would be usually, and you can name it whatever you want, but typically you're going to call this first term 1. I could call it the fourth term if I wanted. Then this term right here would be 2, and by the way, A1 would be 5. You know that, right? So A1 would be 5. And here, A2 is 9. Here, this is the third term, so n is 3, and A3 would be 13. Okay? So, typically, and again, you don't always do this, but typically you're going to start with the first number on the list. Okay? This goes up to the 20th term, so I am guessing that this is the 20th term, and I'll talk about that in a minute. Maybe it isn't the 20th term, but I'm guessing it's the 20th term. And then this is the formula that generates that sequence. Okay? So I am going to have you go to your calculator, and it gives you some directions for how to do this, and I will follow it on there, and we'll learn more about these formulas in a minute. All I care about right now is just you being able to work your calculator, and I'll talk to you later about how you get the numbers below that sigma symbol and in the formula and everything. But for now, let's just focus on our calculators. Okay, so I'm going to have you go to your calculator. I want you to look at the directions that are both in your notes and on this slide right here, but I'm switching slides, so you'll have to look at your notes. Okay, so to find the sum, I want you to go second stat, which is right there. So second stat. And then I want you to scroll over to math. So use your right arrow and scroll over to math. And then I want you to do number 5, which is sum. Okay, so that should pop up. Then you need to do sequence, which is second stat. Again, over to math. No, over to ops, sorry. And then sequence, which is number 5. So I'm going to sum the sequence. Then I'm going to put the formula in. The formula in this case was 4n plus 1. You're going to have to put x in. So 4x plus 1. And I missed the plus sign here. Then you need to put the comma. The comma is right above the number 7. Then you need to put the number that's below the sigma symbol. In this case, it's 1. And then the number that's above the sigma symbol, in this case it's 20. And then close your parentheses and hit enter. And I am getting an error. And what did I do wrong here? Oh, whoops, I forgot to put my x in. So, sorry, I have to put my formula, and then I have to do comma x, comma lower number, comma upper number. You guys probably caught my mistake. And then let's try it. And I'm still getting an error. And I don't know why. Okay, I'm going to start over. All right, second stat. Over to math. Number 5. Second stat. Over to ops. Number 5. Then I need to put the formula in. So 4x plus 1, comma, x, comma, my lower number, comma, my upper number, and I will close that. There we go. And I got 860. I'm not sure what I did wrong, but I got it fixed for you. So you probably are making some similar mistakes. Okay? So there we go. The sum of that sequence is 860. So when I add all the numbers up in that list, 5 plus 9 plus 13 plus 17 plus all the numbers in between plus 81, I should get 860. Okay? So your calculators, when you do the sigma, will be very, very helpful. All right, here we go. Second one, use the first 50 positive odd integers. So let's just think about this. Positive odd integers. The first positive odd integer is 1. And then it goes 3. And then 5. And then 7. And I want to go until I get the 50th number on the list. So this means that there's 50 terms, or there's 50 numbers on the list. Okay? I want to sum the first. It doesn't mean that the last one is 50. It means that there's 50 numbers on the list. I want you to do sigma to do this. So we are going to use this formula that's right here. This does happen to be an arithmetic sequence, and because it's an arithmetic sequence, you will use sigma, and then of course you'll use this formula right here, which is the formula for an arithmetic sequence. Okay? So when you do this in this case, you will do sigma, okay, and I'm going to plug things into that formula and I'm going to simplify it kind of off to the side. Okay, so in this case, an would be a1, and the first term is 1, plus, I'm not going to put a number in for n right now, and then 2. Okay, all I'm trying to do is I'm trying to simplify that formula with this specific information. So in this case, the first term is 1. When I distribute that 2, I get 2n minus 2. So I get an equals 2n minus 1. Okay, so I always want you to take the formula and simplify it as much as you can, and then go ahead and write it in sigma notation. So in sigma notation, my formula is simplified. This formula right here, with everything plugged into it and simplified as much as you can get it, would be 2n minus 1. Then down here, obviously I want you to sum up the first 50 terms. So I want you to sum from the first term all the way up to the 50th term. Okay, that's all you need to do here is you're going to sum from the first term all the way up to the 50th term. And once you get that, then you can go ahead and stick this into your calculator. So let's see if I can get this right this time. I will clear this out so it doesn't mess us up. So I am going to go second stat again, over to math, number 5, and then second stat, over to ops, number 5. I will put my formula in, which in this case was 2n. I'm going to use x minus 1, comma, x, comma, my lower number, or the first term that I'm going to start summing. I'm starting with the first term, and I'm going to add all the terms up to the 50th term. Okay, so comma 1, comma 50, close, close, hit enter, and I should get 2,500 when I add up the first 50 terms of that sequence. So 2,500. And that's actually the answer that it goes right here. This is the answer for part A, and the 2,500 is the answer for part B. All right, this time we're dealing with a geometric sequence, and so I want you to sum up the first 8 terms, and if I ask you to sum up the first 8 terms, I may write it like this, sum of 8 terms, and when I do that, I get 765, and I'm telling you your common ratio is 2, and your goal in this case is to figure out what the first term is, and to figure out what the first term is, that's A1 in the formula. Okay, so I will plug in what I know, and what I know into this formula is that the sum is 765. I don't know the first term. That's my goal of trying to figure that out. 1 minus, my ratio is 2. I am summing up 8 terms, so my n will be 8. All over 1 minus r, which of course is 2. Okay. So when I simplify this just a tad, then I have my first term. 1 minus 2 to the 8th, if you stick that into your calculator, will give you negative 255. And then, of course, on the bottom, 1 minus 2 is negative 1. Okay, then you want to get rid of that fraction, and so I will multiply by negative 1. And obviously that's going to cancel, and I will have negative 765 equals A1 times negative 255. And then to solve for A1, I will divide by negative 255. And your first term, when you figure that out, will be 3. Okay. All right, here's another sequence, or series actually, because I'm asking you to add. I want you to be aware that this really, when I know I have subtraction in there, but that's the same as adding a negative. So I can change these things to adding a negative. So if I have to think about this, am I adding or subtracting to get to the next number, or am I multiplying or dividing to get to the next number? And in this case, if I take this, I will actually multiply by negative 3, and then negative 6 times negative 3 is positive 18. 18 times negative 3 is negative 54. So because I'm multiplying, this is actually a geometric sequence. And so I'm first of all going to do this formula by using the sum formula, okay, so that we can get a little practice with that. So when I use the sum formula, here is kind of the problem, okay? So I'm starting with that formula, and the problem with me using that formula right off the bat is this. I know that this is the first term, so n is 1. This is the second term, so n is 2. This is the third term, so n is 3. The problem is I don't know what term number that is right there. Okay, I don't know it. And when I use the sum formula, I need to know how many terms am I adding up. I know that 118,098 is the last term I'm adding up, but I don't know what term number it is. Okay, so I'm going to have to figure that out. And to do that, you're going to need to go back to your other formulas that you have, which this is the formula for a geometric sequence. It goes like this, just to jog your memory. And so what I need to do is I need to use that formula to help me find what n is. So an is 118,098. My first term is 2. I'm multiplying every time by negative 3. Okay, again, don't take the 2 times the negative 3 and make that be negative 6. That's illegal. So divide by 2, and you'll get 59,049 equals negative 3 to the n minus 1. And then 59,049 is a power of negative 3, and you probably don't know what it is off the bat, but you're going to have to guess. So, and make sure you put it in parentheses. So try putting in parentheses, negative 3 to the 7th power, and see what you get. Negative 3 to the whatever power. Make sure you put the negative 3 in parentheses. Guess until you get 59,049. And if you take negative 3 to the 10th power, you will get 59,049. And this is the same as negative 3 to the n minus 1. So of course, since I have them in common bases, 10 will be n minus 1, and n will be 11 then. Okay? So, Houston, we have a problem. The problem is we didn't know what term number that was. Okay, so I have now solved that problem. So I will find now S of 11. So I know I just figured out that this right here was the 11th term on the list. And again, I did that with this mumble jumble mess over here. Okay? So here we go. I'm finding the sum of the first 11 terms then. Now that I know that, now I'm golden. Okay? So I will follow the formula. Your first term right here, A1 is 2. And then you'll go 1 minus. Your ratio we know is negative 3. I know I'm summing 11 terms up. And then 1 minus negative 3. So be really careful with the signs. Okay? When I do that then, I will have 2 times 1 minus, and when I take negative 3 to the 11th power, make sure you put that in parentheses. When I do that, then I get negative 177147. And then, of course, on the bottom, minus a negative can be added, and I'll get 4. Okay. I'm going to move this, Houston. We have a problem business. And then when I add this, obviously I can do that. 2 divided by 4 is 0.5, so I could do 0.5 times 177,148 if I wanted, or stick this into your calculator at this point. I know you're fine right here. So 88,574 is what you would get. Okay, so that's if we use the sum formula. Then if we use the series or sequence formula, and I go over here, this is what I will use. Notice that since this is a geometric sequence, I will put this right here because that's sort of the generic form for a geometric sequence. Again, when you use sigma, you have to tell me which term numbers you're summing up. So in this case, I'm summing up from the first term to the, and remember, I didn't know what term number this was, so I had to use this part in red over here on the left to figure out. And whether I use the sum formula or whether I use sigma, I'm going to have to do that part in red and use the old school formula and figure out what n was, because I still need to know I'm summing from the first term to the, I didn't know what term that was. But I used my formula and I figured out that it was the 11th term. Okay? And then when I did that, I know I'm plugging things into this formula now. I know that this is 2. I know my common ratio is negative 3. And then, of course, I have it to the n minus 1 power. Okay? You cannot take 2 times negative 3 and make that be negative 6 to the n minus 1 power. So this is as simple as it can get. That's all the formula is. But now, of course, you need to put it into your calculator. Okay? So we will practice that again. So I will go to my calculator. Maybe. My calculator's not wanting to work. Here we go. Math over, or sorry, not math. I want to go second stat. There we go. Over to math. Number 5. And then second stat. Over to ops. Number 5 again. You need to put your formula in and you have to be really careful. My formula in this case will be 2 times parentheses negative 3 to the, maybe, it's not going for me, to the, now I'm going to put my exponent in parentheses. If you have one of the newer calculators, your exponent probably comes up in the box, and then just right arrow over once you get out of that box. But I need to put it in parentheses because I have an old school calculator here. So x minus 1 is my exponent. Okay, so I put the formula in now, and then I will go comma, x, comma, my lower number, which was 1, comma, my higher number, which is how many terms I'm summing up. In this case, I'm summing up 11 terms I figured out. Close that. And again, I should get the same answer, 88,574. So you can do that either way. Okay? All right, moving on, you guys. I apologize that this is going to be kind of a long video. Similarly, find the sum of a geometric series for which the first term is 7,766, or 776, and the nth term is 6. The common ratio is negative 1/6. Okay, so if I were to do that using the sum formula, here's what would happen. If I use this formula right here, okay, and you can choose to do this either way, but the problem is I don't know n, okay? If I plug that in, this is my deal. I know if I use this, s of, I wonder how many terms I'm going to need. I don't know. All I know is the last term that I'm adding up is 6, and I don't know what term number that is, and I don't want you to sit and make a list, okay? So I know the first term is 7,776. I know I'm going to go 1 minus my ratio, which is negative 1/6, to the, I don't know what number needs to go there. Okay, I don't know that. Sorry, I should move my parentheses over so that's not confusing you. Okay, all over 1 minus negative 1/6. Okay. Problem is, again, I don't know that term number. So let's say that I wanted to use sigma. Okay, if I wanted to use sigma, I'd have sort of the same problem. My first, again, this is a geometric sequence, so you need to use sigma with this. My first term is 7,776. My common ratio is negative 1/6 to n minus 1. I know I'm adding from my first term to my, I don't know what number to put there either. Okay, so again, you're going to have to go back to this formula. Okay, and these are fractions. I know this is kind of ugly. The an in this case is 6. The first term is 7,776. My ratio is negative 1/6 to the n minus 1. I will divide by 7,776. And then I'm going to hit math, enter, enter. 6 divided by 7,776, hit math, enter, enter. And you're going to get 1 over 1296. Okay, and now you're probably going to need to just worry about the denominator. Okay, so you should be able to write 1,296 as a power of negative 6. And hint, 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 notice it's a positive number, so it's probably going to be an even powered. But guess, is 1,296 6 to the third, 6 to the fourth, negative 6 to the fifth, negative 6 to the sixth? What is it? And you're going to put that in. Make sure you put the negative 6 in parentheses when you do that. And it will be 1 over negative 6 to the fourth power. Okay? So you'll sort of have to guess, and then I can remove my bases because they're the same base. And then, of course, n will be 5. So when I do this, it is 5 that I want to put right here, and right here, and right here. And at this point, you can either simplify this formula, or you can go to your calculator and put it in. But you should get 6,666 when you do that. So you go ahead and do that and check it. All right, this again is sigma notation, and it's asking you to write it as a sum of terms. Notice what I'm doing here is I'm summing up the fourth term all the way up to the eighth term. Okay? All you have to do when you do that is you just plug the numbers in, and you're going to do each term separate. So the first thing I'm going to do is I'm going to find that, and I am going to plug 4 in. So I will go 2 times 4 squared minus 3. And when I do that, I get 29. Okay? The next time I'll plug 5 in. 2 times 5 squared minus 3. So I start plugging in the number that's down here. So the first number I plugged in was 4. Then I'm going to plug 5 in. Then I'm going to plug 6 in. Okay? When I do that, I get 47. Then I will plug 6 in. 2 times 6 squared minus 3. When I do that, I get 69. Then I will plug 7 in. When I plug 7 in, I get 95. Then I will plug 8 in. And when I plug 8 in, I get 125. And then I stop because this is my number up here. Okay, now all this asked me to do was write it as a sum of terms. It didn't ask me to find what the sum was. If I asked you to find what the sum was, then of course you'd add all those numbers up. But I just want you to write it as a sum of terms. So this is what I need right here. Okay? And the last one. Write this in summation notation. So you want to find the formula that will generate that series that is listed up above. Okay? So what you're going to do to start with is you're going to start with this bottom number. You're going to plug it into the formula, and you're going to see if you get this first term right here. Okay, so when you plug in the bottom number, you should get that first term. So let's check this out. If I go x to the 1 over 1 plus 2, that gives me x over 3. That does not give me negative x to the 5th, which I should get when my first term, so I know that that's not it. Okay, then I'll go over here, and I'm going to, again, plug in this first number and see if I get the first term. So is negative 1 times x, notice you have to plug it in for n, not for x, to the 0 plus 1 over 0 plus 5. Does that generate it? So I have negative 1 times x to the 1 over 5. Ooh, that gives me it. So now I'm going to check my next term. This is definitely a possibility. Okay, now I'm going to plug 1 in. I'm going to just kind of do this. Now I'm going to plug the next number in. So since I plugged 0 in first, I'm going to plug 1 in next. And when I plug in 1 next, I should get the next term, which is this. So now I'm going to check that out. When I plug in negative 1 times x to the, and I'm not plugging in negative 1, I'm plugging in 1, times x to the 1 plus 1 over 1 plus 5. Okay, that gives me negative x squared over 6. Here's the problem. I got negative x squared over 6, and I should get positive x squared over 6 according to this. My next term right here is positive x squared over 6. So I thought it was there, but it's not. You better check a couple terms because accelerated math, you guys, is going to fool you. Okay? Moving on to the next one. Again, I'll plug in my bottom number right here and hopefully get this first term. So I will plug in negative x to the 1 plus 1 over 1 plus 5. And I get negative x squared over 6. And guess what? That does not give me my first term. So this is not it. And of course, you could continue going, but I will tell you that this is it then. So when you plug in the bottom number, when you plug in 0, you'll get negative x to the 5th, or negative x over 5, I'm sorry. When you plug in the next number, which is 1, when you plug in 1, you will get x squared over 6. When you plug in 2, you should get negative x cubed over 7. When you plug in 3, you should get x to the 4th over 8. And you can check all of those, and they do indeed work. Okay?